Mr. Bijak is my idol. He's a good guy. He's got more hair than I do. It's a good thing. All right, so hi, Rowan. We miss you, Rowan. It must be nice to sleep in, Rowan. We hope to see you back someday, Rowan. Braden, anything? No, he is enjoying the break. Here we go. All right, so you have a function, and what we want to do is we want to take this function. We actually want to take the area that's bounded by it. So suppose I had a vertical rectangle that represented the area beneath this function in the x-axis. And I know that my drawing is limited, but I'm going to do my best. So sometimes our brains are limited as well, right? I need you to do your best to try to visualize what the heck it is that we're going to do. So as you draw these rectangles on here that represent the area, what we're going to do is we're going to take this area that's formed between the curve and the x-axis, and we're going to rotate it around the x-axis. We're going to spin it. See that? So like if you picture taking this rectangle and spinning it, maybe you get that type of shape. Take this one, spin it, maybe you get that kind of shape. Take this one and spin it. Maybe you get that kind of shape. All right, so I hear some good talking, and Alex says, so it's going to be kind of like a cone, kind of. And you're right, except it's going to be solid. Okay, this is solid all the way through. So I kind of tried to draw this blue curve reflected down below, but we're going to get a solid piece generated. Have you ever seen a lathe? Well, volume, that's an interesting question. So let's think about that. Let's think about our original shape. That rectangle, did it have a width of dx or a width of dy? Dx. Is everybody clear on that? That's super important. So I got width of dx. But if you notice, we don't just have a rectangle, we got a slice. It's almost like a disc, huh? Like a disc, right? How would you find the volume of a disc? If you want to find the volume of that guy, we've got this width of dx, but what do we call this part right here? The radius. So what's the area of this? Pi r squared. So you take pi times r squared, and then you would multiply it by the width, which is dx. So everybody see that pi r squared dx is going to be the volume of that one guy? Well, what determines our radius? The height, and the height is determined by the function. See how the function determines our height? So all of a sudden, this volume of this guy right here is pi times the function, which is our radius, squared dx. Now, that's just one of the disks. How many disks do you think we actually generate? An infinite number. How do we add up an infinite number of things? You slap on an integral. Okay, see how ridiculous that sounds? Like we go from doing one to doing an infinite. You're like, oh, no big deal. Just put the integral there. Well, that's like a big deal. So I've got pi. We like to write the pi on the outside. The function squared dx, and we go from a to b, whatever the bounds are. you're more than welcome to. Here we go. Let's try an example. Find the volume of the area bounded between y equals the square root of x equals 4, and x equals 0, rotated around the x-axis. Let's start to see the space that we're actually working with. Y equals square root of x. What the heck does it look like? Not really, but the bird functions like that. It's like a bird that got cut in half. It's like the cow on the side of the road this morning. Actually, he wasn't even cut in half. He was just... All right. It was a steer. All right. So we got square root of x. X equals 4. What does x equals 4 look like? What does x equals 0 look like? Yep. So, and if I rotate this around the x-axis, can you see that this is the area right here that I'm going to be working with originally? Okay, and I'm going to spin that around the x-axis. And as I spin it around, what shape does this rectangle create? Okay, Braden is correct that the shape as a whole will create kind of like a cone, but this rectangle just creates a disc. And the idea is we can find the area or the volume of one small thing, we can then make an infinite number of them to find the volume overall. So again, some people say, well, where do you draw the rectangle? Folks, you can draw the rectangle anywhere you want. It's just a matter of trying to create that shape. And, we'll run it from the beginning to the end. Some people like to draw it on the end, and I like to draw multiple ones because it's like art class. It's a really good time. It's like half of a ham, huh? There we go. A ham, like a Easter ham, you cut it in half. Never mind. Okay. Is my width dx or dy? Dx. I got to find the volume of one. We know that we do pi times r squared dx if we're using a disk. Well, what is our radius? Our radius is the square root of x. So therefore, the volume of one of these disks becomes pi times the root of x squared dx. What is the root of x squared? Just x. So that's one of them. How many do we want? An infinite number. How do we get an infinite number? Slap on an integral. Pi x dx. What are my bounds? In order to determine your bounds, dy on is right. You go from 0 to 4 in this situation. Always look at the original area. So the original area, we're going to go from there to there. And so, wherever you think about the original area, that's going to tell you your bounds. Go from 0 to 4. All right? Well, what's the antiderivative of x? X squared over 2, so pi x squared over 2, evaluate 4, and it's 0. Plug in the 4, 16 over 2 is 8. I get 8 pi. That's the volume. It's not bad at all, and it's pretty cool. What do you think? Don't think that way, Braden. Find the volume of the area between y equals x squared plus 1, x equals 0, and x equals 2, rotated around the x-axis. Okay. Get me started. Parabola. Now what? So I got x equals 0. I've got x equals 2. And I've got this function. Can you see the space? A lot of times in the AP exam, they're going to give you the space. You don't have to create it. But in this situation, you know, it's more helpful if we could create it on our own. Clap when she comes in. Okay. I'm going to rotate this thing around. I'm going to try to draw it as it's rotated around. Thank you. And I'm going to draw a rectangle that gets rotated. Maybe try to describe the shape that I'm getting. Okay. Almost a trapezoid. Try to describe it in a three-dimensional sense. If you're going to compare it to a natural object that you maybe see. A bell, okay. An anvil, I like that. What? A bowl? I like to think of it like this. If you were to lay it down, it might be like a tree stump. How's that? You like a hat better? Okay, except it's not hollow, so. A music what? A music rest? You're serious. That's something? Okay. Oh, I got it. Okay, I know what you're saying now. All right. So there we have it. Everybody good with it? All right. So I've just got to find the volume of the disk. It's a disk. A disk goes pi r squared. The width is dx on this guy. So now what? What's r? X squared plus 1. Pi times x squared plus 1 quantity squared dx. That's the volume of one of the disks. How many do you want? Slap on the integral. What do we integrate from? 0 to 2 pi, and I multiply out. I get x to the fourth plus 2x squared plus 1 dx. Sweet. And I derive x to the fourth. X to the fifth over 5. 2x cubed over 3. Plus x evaluated 0 and 2. 2 to the fifth. 32 over 5. 2 to the third times 2. 16 over 3. Plus 2. 0 gives me 0. Common denominator? Pi times, let's see, it's going to be 96 over 5 plus 15, 80 over 15. I was just writing the 1. It's not like I forget that stuff. Don't make mistakes. 30 over 15. Yeah? Add them all up. $216 pi. Shut up, Riley. 206 pi over 15. Sounds good. You know, I've made many mistakes as I've done practice AP exams by forgetting to put pi on the end there. That will definitely cost you points. Nope. No half points on the AP exam. Maybe. I know what I'm going to talk about in the hallway after this class. All right. Very good. You keep that up, buddy. All right. Find the volume of the area bounded between the curves. Y equals 1 half x plus 1. X equals 0. Y equals 3. Rotated around the y axis. What's different? I heard a groan. I heard a few groans. It's around the y axis. That's what's different. Let's think about it. You love dy. It's like your thing. Good for you. Okay. X equals 0 and y equals 3. What is x equals 0? It's just the y-axis, so we're going to bound it here. Y equals 3. 1, 2, 3. Like that, right? And 1 half x plus 1. Everybody agree that that this is the area I'm working with? So if I'm going to rotate it around the y-axis, what I want to do is I want to use horizontal rectangles. Kind of see the general shape that you're getting. So my question, yep, it's a cone. Very good. My question to you is the width of the original rectangle, dx or dy? dy. So that means that everything must be in terms of y now. Okay? So I know I have a disk, so I go pi r squared dy. Well, right now, if I plug something in for x right here, that will give me this height. But I don't want that height, do I? I want this length. So if I want to produce an x value for length, I have to change that so it says x equals. So how about we subtract 1 to get y minus 1 is equal to 1 half x, and multiply by 2 to get 2y minus 2 is equal to x. How's that? Everybody agree that 2y minus 2 is going to be my radius? So therefore, I have pi times 2y minus 2 quantity squared dy. That will be the volume of one of the disks. I want an infinite number. Yep. As you look at your original area right here. So if I were to draw discs, so this is where people get confused. I was letting kind of people think about it for a while, but if I were to draw a disc here, okay, you could see, I'd get that space down there. But where would I start drawing discs? I'd start drawing discs at 1. Where would I end drawing discs? I'd end drawing discs up here at 3. And again, those must be y values because we're dy. You have to look at your y values. Questions? All right, let's go. Pi times the integral 1 to 3. Multiply it out. What do you get? Minus 8y plus 4. antiderivative, 4y cubed over 3. What's the antiderivative of negative 8y? And then we have plus 4y. We plug in 3. 3 cubed. Divide by 3 times 4. Let's see. 3 squared is 9 times 4. Well, that's handy. Plus 12. Minus. Plug in 1, I get 4/3 minus 4 plus 4. Very good with that. See some nice things to cancel. 36s are gone. 4s are gone. Got 12 minus 4/3. Or 36/3 minus 4/3. Or 32 pi over 3. This was our original area, right? So if you're going to find the area of that, you're going to do dy, you're going to find the area using dy, you would have to use y values. So sometimes instead of looking at the revolutions and the disks, look at your original area. So you can't choose the x values here because it's not dx. You have to choose the vertical values because it's dy of your original space. All right, last one. Find the volume of the area bounded between the curves. Y equals negative x squared plus 3x, x equals 0, and x equals 3, rotated around the x-axis. Negative x squared plus 3x. Upside down parabola goes through what values on the x-axis? We factor out a negative x, we get positive x, and we get a minus 3, right? So it goes through 0 and 3 on the x-axis. Everybody agreed? And it's upside down. Bounded by 0 and 3 and rotated around the x-axis. Yep. It's going to look like a sphere. Maybe a football. Is you draw one of the vertical rectangles and rotate it around. You can see the disk that develops. What up, dude? Thank you, sir. dx or dy? dx. What's my formula for a disk? Pi r squared, dx. What's the radius? I'm going to write as 3x minus x squared. That's just how I like to work. Free country. Oh, also free to erase all the work that you had. Integrate from? Thank you. Square that out. What do you get? Yep, 9x squared. I multiply these, I get a negative 6x cubed plus x to the fourth. And I derive 9x squared. 3x cubed. And I derive negative 6x cubed. X to the fifth over 5. Evaluated 3 and 0. Plug in the 3. 3 cubed times 3. 81. 3 to the fourth times 3. Very good. Yep, 3 to the fourth is 81. Times 3 is actually 243. That's where we're going to stop. We're going to stop at 243. Right? Yes. And then x to the fifth over 5, 3 to the fifth. That's another 243. Nobody said we had to do it by hand, did they? Riley? Am I okay to use my calculator? Thank you. 81 minus 243 over 2 plus 243 over 5. Math, convert to fraction. 81 pi over 10. Isn't that fraction button incredible? There you have it. Volume by discs. Do you know what you're doing? Okay.